Indices and algebra. Simplify using your knowledge of indices. So let's just reorder these so that we bring the 3's together and the 5's together. Now we know that when we're multiplying these, we add the indices. Remember, the bases have to be the same, which is why I brought the 3's together and the 5's together. So 4 add -1 is 3. And then 5 add -2 is also 3. So we end up with 3 cubed times 5 cubed. Now if we go for this one, what I'd probably do here is sort out the top first. So the ones with the same bases we can put together. 3 to the 4 times 3 squared is 3 to the 6. We add the indices when we're multiplying. And remember, this just 5 is a 5 to the 1, but we don't normally write the 1. So 7 add 1 is 8, so we get 5 to the 8. That's divided by 3 cubed times 5 to the -2. Now when we're dividing, we subtract indices. So 3 to the 6 divided by 3 cubed, you do 6 take away 3, and we get 3 to the power 3. Here with the 5's, we subtract the indices. 8 take away -2 becomes 8 plus 2, so that one would be 5 to the power 10. Now exactly the same idea here. A to the 5 times a cubed, so I'm bringing the a's together. B to the 4 times b to the 4. Now we have the same base here, they're both a. So when multiplying, we can add the indices. So that's a to the 8. And the same thing here with the b's. 4 add 4 gives us 8. And using good algebra, we should write that as a to the 8, b to the 8 without the multiplication sign. Now here we have another index law in play. We know that if we have a to the m and we then raise that to the n, it's a to the m times n. So a to the 5 then squared becomes a to the 5 times 2, which is a to the power 10. With the b here, that's going to be b to the power 8. And then we're multiplying by a cubed and by b to the -5. So dealing with the a's, because we have the same base there, so when multiplying, we can add the indices, and that gives us a to the 13. With the b's, we're multiplying, so we add the indices. 8 add -5 is 8 take away 5, so that's b cubed. And then using good algebra, we would not have the multiplication sign in there. So just a to the 13, b cubed. Simplify using your knowledge of indices. Well, this one's more straightforward than it looks, because we know that when we divide, we subtract indices. The bases have to be the same. So looking at the x's, x to the 4 divided by x squared, so we do 4 take away 2, and that gives us x squared. Looking at the y's, y to the 6 divided by y cubed, so 6 take away 3 is 3, so we get y cubed. And then we have z to the 8 divided by z to the -1. 8 take away -1 is 8 plus 1, so we just get z to the 9. Moving over to this one, we've got another index law in play. If you have something like PQ to the R, that means that the P is to the R and the q is also to the r. So here the a cubed is to the power -3, and so is the b to the -2. Then we have times a squared times b to the -1 all over a to the -10 times b. Now when you have a complicated problem like this, it's very important just to go step by step. Now we've seen this index law. We multiply the indices here. So that's a to the -9. Multiply the indices here, so that's going to be b to the +6 times a squared times b to the -1 all over a to the -10 times b, and remember that b is to the 1. Here we're multiplying, so we add the indices, so that's going to be a to the -7. Add the indices, 6 add -1 is 5, over a to the -10 times b to the 1. And now we're left with dividing, where we subtract the indices. So here we'd be doing -7 take away -10, which is -7 add 10, so that gives us an a cubed. And here 5 take away 1 gives us b to the 4, and then lose the multiplication sign, so a cubed b to the 4. Now finally here we have 7 to the power 7. Now this a squared is going to be to the power 5, and the b to the -1 also to the power 5. Once again, it's using this index law just here. On the bottom we have 7 cubed times a to the -1 times b to the -11. So that's 7 to the 7. Remember, here we multiply indices, so that's a to the 10. And here we'll have b to the -5 all over 7 cubed times a to the -1 times b to the -11. And then we just have division, where we subtract indices. So that's 7 to the power 4 multiplied by subtract indices here would give us a to the 11, and subtracting indices here, so that's -5 add 11 would give us b to the 6. So we can say that's 7 to the 4, a to the 11, b to the 6. So here we want to factorize as far as possible. So I'm going to write this out as 3 times x times y, and the 6 I'm going to split into 3 times 2. Then I have times x times y times y. Now let's look at what's common. We've got a 3 in each term. There's an x in each term. And there's a y in each term. So that's equal to 3xy, open a bracket. So what we've done is we removed everything that was common. What do we have left? Well, here we have just an x, then we have a plus sign, and then we have 2y. And that's fully factorized. We can do the same sort of thing here, but note this is x cubed y cubed and x squared y squared. So x cubed I can write as x squared x, and y cubed I can write as y squared y. And then over here we've got 1 times x squared times y squared. And you'll see why I put the 1 in a moment. So common, we have x squared and y squared. So the common things always go in front of the bracket when we're doing this. So we've taken this out, this out, this out, and this out. That's why we needed the 1, because we can't just end up with nothing here. And so we're left with xy, a minus sign, and the 1. And if you try re-expanding this, you'll see that you do get this original expression.